of our students have been able to get placed in good core companies that is related to electric mobility. So before we start, I would like to play this video. Okay, this is a video which has been made as per the data obtained by ranking royals on market capitalization. So market capitalization is basically um, a, a cap which is used to look into what is the profit that a company is making, okay, or what is the net worth of a company. So you can see from 2001, there has been a lot of companies which have been into the automobile sector, and Toyota has been always the leader. From 2001, we can see it is leading. So this has been a trend during that time when a lot of new companies were also coming in. We can see Tata Motors is also there. We have Ford, which has already left India. Then we have the top three are always between Benz, Toyota, and Honda. So this has been going on from 2001. Now in 2008, we have Tesla coming into picture, right? So Tesla, Elon Musk, who was the co-founder of PayPal, he invested into Tesla, and he gave around 30 million US dollars during that time, and then he invested a lot into Tesla. And so in 2008, Tesla came out with their first electric vehicle. Hope all of you have heard about Tesla. So Tesla Roadster was the first electric vehicle which came into market, right? And that had a range of around 394 kilometers. That is around 400 kilometers during that time. So that was actually a game changer, because all the electric vehicles that we have been seeing till now has not been aesthetically good. If you remember the old not Mahindra, the Reva vehicles, you might have seen that the box type vehicles, which doesn't look much good. So it doesn't have that appeal. But Tesla Roadster was completely different. It was like something like we can compare with a Ferrari, right? So it was very attractive, and that was actually a new thing for the world as such. So Tesla then in 2012 they introduced Tesla Model S, right? So Model S was also a big hit, right? So their sales started increasing, and around 2016-17 they started the Gigafactory, where they were manufacturing their own battery packs, their own charging station. Now you can see Tesla by 2017 reached the top 10 richest automakers. So they were gaining their market. So you can see 2018 Tesla has been increasing, and then you can see there is another company which is also coming in. There is BYD, which is a Chinese electric vehicle company, which is also coming in. So by 2019, that is by the start of pandemic, you can see after the pandemic what happened. Tesla's growth has been phenomenal. Okay, so as of now, that is by around 2021 quarter two, I think Tesla has surpassed Toyota, and you can see it is almost 3 times the net worth of Toyota. So you can see Toyota is around 214,420.
Sorry to interrupt.
Yes,
The
yes, sir.
screen share item.
What is it?
The presentation is not visible.
Oh, it's not visible. Okay, okay. Okay.
സ്ക്രീൻ ഒന്നുകൂടെ ഫുൾ ആയിട്ട് ഇപ്പോൾ ആയി വരുന്നുണ്ട്.
Okay.
Okay, it's fine.
Yes.
Yeah.
So yes, sir. So this was the video which I was playing. Okay, so you can see it introduced, it increases, and around 2017 Tesla comes into the top 10. Okay, so Tesla's growth is increasing, and by around 2020 Tesla becomes the leader. Okay, so by quarter two, that is around April May 2021, you can see it is around 647,710 million US dollars worth market capitalization for Tesla, and then BYD is also there. You can see 66,150 million. So that is the market capitalization. So this is actually an indicator of what is happening towards the automotive market. Okay, so when we look at the automotive market in the world, Tesla has shown that there is a very much high interest towards electric vehicle adoption, and this electric vehicle adoption is the future that we can foresee. So even though IC engine based vehicles are still existing in the market, there are different countries which have already taken up policies to slowly eliminate the usage of ICE engine vehicles and move towards more greener options. Okay, there are very varied reasons for that. It includes your pollution, your increasing fuel prices, right? So and fossil fuel depletion. All these are some of the factors which are part of that. So this actually is a great opportunity for engineers. We are all engineers, so as engineers, we have a lot of scope in exploring this. Right. Something like it. This offers us a interdisciplinary platform for research as well as for making up a career. So it doesn't mean that only electrical students are going to get jobs in electric vehicle industry, or only computer science or mechanical students are going to get. All of us will get jobs and opportunities if we are having some kind of knowledge on an interdisciplinary platform where we can understand what is or how a motor works, right? If we know how to do a Python coding, right? If we know how to operate, or how does a mechanical powertrain operate, how does a differential work, right? So how does a anti-lock braking system work? How does a adaptive driver assistant ADAS system work? How does a sensor capture information? How is the sensor information transferred? Or if we have this kind of knowledge, it is actually going to be a good game changer for us in the terms of career as well as future. So these are some of the research verticals which we can look into as engineers. As engineers, it is not, as I told, it's not defined to any particular stream, but it can be anyone from the engineering stream. Even civil students can also participate in such research areas. So, what are the areas? We have battery management system and energy management system. Now, India, as such, doesn't produce much of battery packs. Okay, we are mostly depending upon countries like China or Brazil for importing lithium. Right, we don't have any manufacturing plants much in India. Most of the manufacturing is happening in China, where they will be importing lithium from Brazil or the South American nations, and they will be making this lithium-ion cells. So lithium-ion cells typically will be very much familiar with the 18650 cells, which are those cylindrical cells which are available even in our laptops, and all will be using those cells. So those battery packs are very critical in the case of vehicle technology or electric vehicles, because when we talk about electric vehicles, earlier we used to have lead acid batteries, right? So lead acid batteries, if you know, most of all our conventional IC engine vehicles have a battery pack in that. That is a small 12-volt battery pack, if you have seen that. So that battery pack is a lead acid battery pack, right? So as compared to lead acid battery pack, when we compare a lithium ion battery pack, the lithium ion battery pack is going to be much more energy dense as well as power dense. Okay, what I mean by energy density is, or power density is, we can deliver more power out of a smaller battery pack. That is what is actually required. Okay, so lithium ion has that capacity or capability, and that is why lithium ion is becoming very popular. And most of the applications, even automotive application, we are primarily depending upon lithium ion battery packs. But the problem with the lithium ion battery pack is they are highly volatile. So there are chances that if I overcharge, okay, or if I over discharge the battery pack, it can cause damage to the battery pack. So in such scenarios, we should have a proper battery management system to protect the device. So that is one very crucial area which most of the companies in India is investing a lot, because battery management system helps us to predict the state of charge of the battery pack. That is, the if you look at your mobile phone, I'm just telling in simple terms, you might be knowing this, but for those who are not knowing, if you see at inside your mobile, you can see at the right top, you can see that there is a percentage shown, 84%, 56%. That shows the SOC of the battery pack. That is the state of charge of the battery pack, right? So that knowledge is very critical when we talk about electric vehicles, because we always will have that range anxiety. If I'm going early morning to my office, right, and if the charge I am not knowing, right, what is the amount of charge that is left, I'll always have that anxiety that whether I'll be stuck on the road. And if I am stuck on the road, then there is no option, right? If it was a IC engine vehicle, I can just take a bottle, go to the near petrol pump, and get some fuel and pour it and drive off. But electric vehicle, that we cannot do, right? So it is very crucial that SOC, state of charge, should be shown, as well as the estimated range of the vehicle should also be known. We should know what is the range that I can expect with this vehicle. Will it drive the distance that I want? So battery management system, along with that, energy management system is also important. Now, what is energy management system? When we talk about electric vehicles as well as hybrid electric vehicles, now in hybrid electric vehicles, what we have is two different sources. It can be an IC engine vehicle along with a battery pack, or a electric drivetrain. So the IC engine can be the ratio can be different. IC engine, 80% IC engine drivetrain and 20% electric vehicle drivetrain, or it can be varying ratios based on which we classify it into micro hybrid, mild hybrid, full hybrid. Then we have range extended electric vehicle. Different classifications are there. Now, in such a scenario, it is important that we have to know when to switch between the electric vehicles and hybrid electric vehicles. So there also we have to know how to manage the energy between the electric vehicle and hybrid electric, IC engine. So that is where energy management system also comes into picture. Okay. Now these areas are also booming a lot, because now even with the new budget which has been proposed 2 days back, they were giving a lot of emphasis on electric vehicle system development. So they are providing a lot of subsidies to various companies which are interested to enter the electric vehicle market. There are different schemes. We had the what is that, National Electric Mobility Mission Plan 2020, which was the first step which they had launched. After that, they had the FAME, fast adoption and manufacturing of hybrid and electric vehicle, FAME 1, FAME 2, right, under which a lot of subsidies are provided to for companies which can, or startups which want to get into the automotive industry, specifically in the electric vehicle domain. Okay, so then we have a lot of research areas like automotive electronics, where automotive electronics, basically we talk about vehicle to vehicle communication, or we want to have vehicle to infrastructure communication, or inside the vehicle communication, which we can also relate to autonomous vehicles, because this is going to be the future. Even if we don't agree that in India, with this high amount of traffic, it will be difficult to have autonomous vehicles, but still we can foresee in maybe in 20 to 30 years, we might have some kind of autonomous, maybe level 1. There are different levels of autonomous: level 0, level 1, level 2, level 5. That is SAE levels. So maybe we can have at least level 1 or level 2 autonomous vehicles. Level 1 is already existing. We have these vehicles which can self-park. Right. You might have seen this even latest one. Recently I have seen where we can actually, that is Kodak, that is Kodak has this self-parking coming in. So a lot of the higher end vehicles have this self-parking. So that is level 1 of autonomous. So same way we can expect a lot of vehicle technology which are going to support this autonomous vehicle industry to come in India. Then vehicle dynamics, this we can relate it to maybe an anti-lock braking system, or you have adaptive driver assistant system. That is also a part of autonomous vehicle, where we control the powertrain based on what is the requirement. Then for ECU tuning and GPU based VCU development, that is vehicular control unit, this is also a very important area. Mostly when we talk about AutoSAR and all, AutoSAR is one software which is industry approved platform, where they are developing ECU modules, which can be used to develop ECU modules. So that is also a very good area of research to work on. Then the major core electrical area, that is power system dynamics and the electric vehicle charging infrastructure, right? So when we talk about this, we have to talk about how well can our infrastructure handle this influx of electric vehicles that we can foresee. Because in India we have this conventional grid which has to be now changed to smart grid, right? So smart grid will facilitate us to have microgrid systems where we have renewable energy sources coming into the grid, right? Along with that, if that support is not there, then electric vehicles charging might be a big issue on the conventional grid, because our grid might not be able to withstand the amount of energy that is drawn by the electric vehicle. There can be voltage sag which can happen, which can actually damage the grid. So we should have some kind of mechanism, and lot of policies have been framed out. Indian government is working on that, as well as you have heard about IEEE associations and all. IEEE is also developing a framework for e-mobility, which can be followed all over the world, so that infrastructure pattern can be followed. Right, then ADAS we'll see. ADAS is Adaptive Driver Assistance System. Now, as part of the e-mobility research and development center, we focus on two areas. One is on the development of product, and the other is on research activities. So our UG and PG students are mostly working on product development, Okay, and some of my research team is also, I think, will be joining this talk. So they have been working a lot into the product development area, and since because of lockdown and pandemic we are not able to go in full fledged, but there are a lot of activities which are already been done. Okay, so coming to the charging regulations, these are some of the charging regulations which we follow in India. We have Bharat AC 001, which is a 3.3 kilowatt system, which is a conventional 230 volt 15 ampere AC supply, which we use for charging, and it takes around 6 hours. Okay, so we have in our homes we'll be getting at 5 amps, so we have a special 15 amps port which has to be given for charging. These vehicles are subjected to that Tata Tigor EV, Mahindra E2, Mahindra Euro. Then we have the DC charging, Bharat DC 001, which is a 15 kilowatt system, right? So fast charging can be, this can be called as a fast charging, because you can see around 200 amperes DC supply will be provided to that, right? And the DC voltage, or it will be a separate charging port which will be available. So it's a 48 volt, 60 volt, or 72 volt based on the type of vehicle we have. In our lab, in our e-mobility research and development center, we have a Mahindra E2, which is a 48 volt 200 ampere lithium ion battery pack which is there, and we use only Bharat single, I mean AC charging. DC charging is not possible because we have to have separate infrastructure developed for that. So we are working on that, but as of now we have only AC chargers. Then you can go for ultra fast charging, where we have CCS and CHAdeMO charging, which is 72 kilowatt systems. You can see CCS is 50 kilowatt and CHAdeMO is 50 kilowatt, and they are operated at a range voltage of around 200 to 750 volt at DC, and so that is going to be very high voltage, and you can have the charging done in around 50 to 60 minutes and all. Okay, that depends upon the battery pack. Okay, so typically you can have it done in 50 to 60 minutes. Then you have AC charging also, three-phase AC charging. So that is a 22 kilowatt system, 415 volt. So that takes around 6 hours. The current will be less in that scenario. Right. So what are the engineering aspects which we can look into? So as I told you, we have different aspects which we can cover. We have autonomous side, where we have different types of sensors, right? So sensors include, we can have LiDAR, we can have radar, right? Even though they are expensive, and Tesla, you might have known, Tesla is not promoting LiDAR and radar. They will be mostly working on camera based, that is our digital camera based system. So Tesla is having already cameras in it. Right. So there are a lot of scopes in this scenario, where we can work on having stereophonic cameras to identify the object, capture the distance from the object, and based on that we can actually try to control the powertrain. Right. And when we plan to control the powertrain, we have to do something like, maybe there is an object detection. We have an object in front of, maybe a car is in front of our car. Right. So when we talk about autonomous vehicle, what should happen is the car should immediately brake, or it should reduce the speed based on the vehicle in front of us. So there, the image or the video which is being captured has to be processed and has to be solved, has to be interpreted and has to be implemented. So all these has to be done in a fraction of a second. So there we have separate controller for or the ECU for the sensor capturing, data capturing, as well as we have another microcontroller or vehicular control unit which is going to control the powertrain. So there are two levels of control happening, and they should be integrated together. Okay, so when we talk about a typical autonomous vehicle, level 3 autonomous vehicle, which is used in US and all, they are saying around 500 TB of data is being processed per hour. Okay, so that is the amount of data that is coming out of the system, and it has to be immediate, because life safety has to be considered, right? So the response should be immediate. So autonomous vehicles, a lot of scopes are there. Then vehicular communication, as we know, inside the vehicle we have CAN bus communication, which is used for ECU to ECU communication, in vehicle communication. But when we go for outside the vehicle communication, we have to look into the VANET, vehicle ad hoc network based communication, or Wi-Fi based communication, or Zigbee based communication, to establish communication with the infrastructure or between vehicles. Okay, so there are in Europe a lot of research is happening on vehicle to vehicle communication, where they are working on platooning, which we'll discuss as we go on. So these are some areas which also has a good scope. Then battery management system, as I told, has a lot of scope, where we have to talk about battery packs as well as battery management system. And then EV motors, electric vehicle motor. So motors, commonly used motors for low end vehicles like our two-wheelers. as well as scooters and all, that is below maybe 500 watts or maybe below 3 kilowatt, we'll be using BLDC motor, brushless DC motors, right? And for above the rating, for cars and all, we'll be using are PMDC motors, and above that we'll be using three-phase induction motor. So based on the different rating level, the type of motor utilization will also change and the control mechanism will also change. So that is also very important. Now, as electrical students, this is one key area that we have to focus upon, that is power electronic converters, because this is actually going to be the key of electric vehicle technology, and this is why most of the IC engine based vehicles are not getting that much promoted, because now you can see when we look at the efficiency analysis of an IC engine vehicle, you can have only around 17 to 23% is the maximum output that you get. If you are giving, say, 100 units as input, 23% or 17 to 23% is the output that you get. So 17 units only you will be getting. But that is because of the driveline losses. But with the inclusion of power electronic converters, even though there are a lot of switching losses and all, the efficiency is much high. Okay, we can get up to 50% of efficiency from power electronic, from the electrical drivetrain. But that depends on the power electronic converter. So if we can have a proper switching mechanism where we avoid the switching losses, we have some resonant converters coming into picture. Right. So all those are areas of interest which we can focus upon. Then charging infrastructure, as I told you, we can look into microgrid based charging stations or a microgrid charging stations where we have solar or wind assisted charging, and along with that, if we have an app based control where we have some smart app based regulation happening, so that can be a smart grid. So smart grid with electric vehicle is actually going to be the future of electrical technology as well as for transportation. So briefly, I'll take you through what we have in the laboratory. So we have some softwares. We have this IPG CarMaker software, which is an industry standard software which we use for calibration of the electric powertrain. Right. So this is a Mahindra E2 electric vehicle which we have. We have opened it and we are working on some subsystems where we are trying to integrate it with the IPG CarMaker software so that we can simulate the subsystems and also try to find out a better alternative, or if we are finding some new technology which we can implement on the powertrain of the electric vehicle. So that is what is happening. Then we have a two-wheeler ABS test bench where we are doing ABS study, anti-lock braking system study on this two-wheeler. So this is a KTM Duke. So we have this driven on a dynamometer. So you can see this is the dynamometer which we have made, and then we have connected it to a system where we have the MATLAB based interaction happening. So from MATLAB we are able to regulate some parameters on the ABS test bench, and so based on that we will be doing the study. So also we have this IC engine tuning system. We have an open ECU which we use. So as you know, this ECU which comes with the vehicles, they are stock ECUs which we cannot program or change. Right, so we have to go for an open ECU where we can integrate it with a maybe a Arduino board, right, and it can be easily connected to a laptop, and we can program or we can tune the parameters which are required. So that is also happening. Then we have some work happening on the automotive sensors. How is the automotive sensor regulations happening? What are the various automotive sensors which are used? Okay, so coming to the e-mobility product development, we have been working on the development of e-bikes mostly, right? So you can see various versions of electric bikes, and this is a small charging station which we are upgrading, right? So you can see this is another charging station which we use. So this is based on solar energy. We can use it to charge this small battery pack. So these e-bikes are actually a BLDC motor, 250 watts BLDC motor which is used, and some of them are 350 watts. So we have a 37 volt 10 ampere hour lithium ion battery pack as well as 20 ampere hour lithium ion battery packs which we use, and this is actually very easy. So if we are looking for doing some projects, actually this is very easy to work on. And how do we capitalize or improve on that? That is where the research components comes in. So we are also working on SOC determination technology. So we have developed one or two SOC algorithms which we are implementing. One is known as the terminal voltage method, which is a very simple method. Then we are going for we have this Coulomb counting method which we have already worked on. Now Joule counting is another area, another type of algorithm which we are working on in the battery management system side. Along with that, we are also working on a deep neural network, because that is actually going to be a very good scope in future, where we have this this ANN or artificial neural network based prediction of SOC, as well as we can predict about the range estimated, all those things, right? So also you can see we have some research happening on the converters. Okay, so this is a BLDC, sorry, this is a inverter which we have been working on, so that we can control a three-phase induction motor. So this is a typical inverter control. So now we are also moving towards developing a resonant converter. So some research is happening on the resonant converter side, so where we can reduce the switching losses and try to improve the performance of the machine. Along with that, we have some battery swapping stations. So this is one key area one of our research team is working on now. Our student team is working on. So this battery swapping station, as you all know, recently I'll show that slide during the budget. There has been a lot of emphasis on development of battery swapping station, how to improve battery swapping technology in India, so that we can commercialize the battery pack. So the one problem here is we have to standardize the battery. Because every vehicle will have a different type of battery as of now, right? So when we go for battery swapping, it should be a standard battery which can be put in any vehicle. So that is one key challenge which will be coming in front, right? Then battery pack development, right? So as I told you, India mostly depends upon import of lithium-ion cells for making this battery pack, and even if you try to buy a battery pack, it will be costly, right? So if you are looking for an entrepreneurship area where you want to develop a project or product, then this is one area that we can focus upon. That is the EV battery pack development. Very simple to do that, right? And also we have inbuilt battery management systems which you can buy from the market itself, very cheap, and you can implement it, or you can invest into the research and you can try to develop good battery management systems which can be implemented. Alright, so this is one such system which we have in our lab. Then you can see we have to also focus upon how to transfer power. Now, as I told you, because we are going to be having a lot of electric vehicles, that how to coordinate the charging, discharging of electric vehicle is very important. So there we can also focus upon how to implement vehicle to grid or vehicle to home power transfer. Right, so that if we have a standalone home, we can use our battery pack to power up the vehicle, thereby reducing the load on the grid, and thereby we can also have a economic model which can be created, where pricing model which can be created, where we are given money for giving or for delivering energy to the consumer. So as if I am the owner of the vehicle, I am giving power. I can transfer through vehicle to grid or vehicle to home to someone else, and we are paid back. So even I think Kerala Electricity Board also has some methods where they are trying to integrate it with renewable energies also. If we have solar rooftops, solar on our rooftop, and we are providing power to the grid, we will be given some kind of amount, right? So such a model has also been lot of work is happening on such models. So that is also a scope where we can talk about vehicle technology. Then coming to the autonomous vehicle side, we can also work on object detection and identification, lane detection, road sign detection. These are all parts of level autonomous vehicle development. But the problem is, as I told you, a lot of data will be coming around 500 TB per hour, with the estimated data from a typical autonomous vehicle, level 3 autonomous vehicle. So that much amount of data, how to process and solve, it's a bit difficult, but at least we can try working on that area. Now, as part of our research team has also launched a product which is known as e-cyclo, which has not been registered as of now, but we are working on that. So this is actually an electric cycle with a charging scenario. So it's like a last mile connectivity model where as in Kochi we have metro, in Bangalore also we have metro. So parking in metro areas is very difficult. So how do we provide parking or how do we mitigate that? For that, we can have some kind of a small charging station with lot of electric cycles, so that people can get down and pay using a mobile app, and then they can take their cycle and they can move off, right, and they can park somewhere, and if it might be parked at some other charging station, and they can leave from there. So such a model is being proposed, and we are working on that. That is called as e-cyclo. Then we have a powertrain. This is actually a hybrid powertrain where we are having a split parallel hybrid electric vehicle. You can see there is a small planetary gear system which is used, and we are sharing power between the electric motor as well as the IC engine. So there also some kind of energy management system has to be developed. Then also on EV forecasting, this is another crucial area. EV forecasting, in the sense, if I am having my vehicle and I have some kind of range anxiety, right? So what if I come up with a model where, an entrepreneur or as a service provider, I am telling you, I will reduce your range anxiety by providing you options. What options? I'll provide you charging options. What are the charging options that I can provide? I can show you or direct you to some charging station which is near to you, right? Or I can direct you to a battery swapping station which is near to you, or I can direct you to a mobile battery swapping station which is near to you. So such kind of ideas are also being researched upon. Yeah, coming to the timeline for banning of ICE engine, as I told you, now these are the timelines which most of the countries have proposed. Norway is expecting to have a complete ban on ICE engine by 2025. Then in 2030, we can see there are a lot of countries, even including India, we are planning to have complete ban on ICE engine vehicles. I don't know how feasible that is, but there are policies now. We can see there are a lot of new policies which are coming up. Then 2032 Scotland, 2040 UK, Spain, and France. I think UK has preponed it to around 2030, so they are planning that also. Now, in India, how feasible is this implementation is a big question, and that is where your vehicle scrappage policy comes into picture. Right, in 2021, vehicle scrappage policy was announced, I think around in October or something, right? During that time, what happened is vehicle scrappage policy is thought to be coming up in 2024, right? And the government is giving you an option, right? If you want to continue using your 15-year-old vehicle or 10-year-old vehicle, then you will have to either pay an extra tax for that, or we'll be allowing you to scrap off your vehicle and we'll provide you subsidy on buying new electric vehicle. Alright, so this is a promotion policy which they are planning. Okay, and that too, if we want to extend the papers of our existing IC engine vehicle, they will be giving it only for 5 years. So every 5 years we have to renew it, and the renewal charges or the re-registration charges will also be very high. So in such scenarios, we will be having that tendency to, why don't we go for a better performing electric vehicle at a subsidized rate which the government will be providing. So that is the mentality, or that is the scenario which has been created. So with vehicle scrappage policy, maybe if it is implemented well, because we have a lot of issues. Where do we scrap these vehicles? We don't have much of scrappage yards in India. Right, like US, we might have seen in most of the movies and all, we have seen a lot of scrappage yards are there. But in India, scrappage yards, especially on vehicle scrappage yards, are very less. So some kind of big investment has to come into vehicle scrappage yards, and then it can be feasible to implement this. So there are some steps which the government is also taking. Right, even Kerala government is also promoting a lot towards e-mobility adoption. Right, a lot of charging stations, electric rickshaws. KSEB is promoting charging station implementation, right? So all the governments are also promoting that. Okay, so this is a framework which has been developed by Deloitte, and Deloitte, it's a big company, and so they are doing a market study on the global scenario, which is expected by 2030. So we can see there is a reduction in IC engine vehicles. You can see it is coming down to around 60%, while the electric vehicles are going, and this is actually an exponential growth curve which will soon get into exponentially, which will grow. Now, how do we support this? Because now you can see a lot of companies in India itself, like Tata, right? Tata has started investing a lot into electric vehicles, right? And Tata EV is also picking up a lot. Along with that, most of the other companies which are coming in, like you have Mahindra. Mahindra has always been in electric vehicle market, and then we have new companies like Nissan is coming in. Right, we have other companies like maybe Volkswagen is coming in. Maruti is starting its hybrid. Hybrid is already launched and is also thinking of moving into electric vehicle. Right, so most of the companies are in India are also starting to invest a lot into electric vehicle adoption. Right, so when we talk about career opportunities in India, these are some easily available things which I have taken and screenshotted. So you can see that there are a lot of opportunities which are coming in. Now, when as an engineer, as a BTech graduate, when you approach a company for a job, maybe a core company like Ola, right? I have a case study where we have a student who was working in his final year project, he worked on a system where we are working on an autonomous braking system, sorry, in the ADAS system, that is adaptive driver assistance system. So he worked on Raspberry Pi for maybe 4 or 5 months on that project, and because of that one project he got into Ola Electric. And as you know, Ola Electric is becoming big, and in Bangalore a lot of Ola Electric charging stations are also coming up. So that is what is expected. So as a engineering graduate, companies mostly in automotive sector will be expecting that you should have some kind of know-how which will make you stand out from the crowd, because as we know, a lot of engineering students are coming out. So how do we capitalize ourselves, or how do we make ourselves more prominent? For that, it's very simple actually. If you have some kind of experience in project, that is, if you are working on final year, please try to work on some hardware projects which can actually add to your resume, and easily you will get into some electric vehicle companies or some subsidiary companies which are working on electric vehicles. Battery management system, if you can work, or if you can work on some kind of powertrain development, say a small electric cycle development, charging station development, or you can work on maybe a sensor, maybe camera based capturing you do, right? You process it, do a lane detection, you make the drivetrain to move along the lane. That these projects are actually going to help you a lot in getting some good job opportunities in India itself, right? And also these are some of the other areas which we are working on, and there is also some AutoSAR based projects which are working on. This is actually very high demand. Those who are interested in learning this, I don't think it is much available even online. MATLAB, if you have access to MATLAB has this AutoSAR toolkit, right, which is available, and you can try installing the MATLAB AutoSAR toolkit and try learning that some basics on AutoSAR. And if you have that AutoSAR in your resume, it is actually going to help you a lot. Okay, so that is one area. Computer science students can work on database algorithm development and database application engineers. A lot of demand is there. So database administrator, sorry, a lot of demand is there, where people want students who are good at computer science and also know something about electric vehicles also. You need not have a lot of knowledge on electric vehicles, some kind of knowledge that a battery pack's SOC has to be determined, that has to be uploaded to the cloud, right? And from the cloud, how do we capture the data, right? Even such small projects will be more than enough for you to get some good jobs in these areas, the database management side. And also the students who are interested in cyber security, right, when we talk about vehicle to vehicle communication, many companies are there who are also interested in this kind of research, where ECU to ECU communication happens in vehicle, that is CAN bus based communication. Or if you can work on maybe vehicle to vehicle communication only, where we have antenna based communication happening, that too also is a good scope. Right, as I told you, AutoSAR, I will not get into detail because time is very short. So AutoSAR is another area which is very good. So if you want, you can just go to MATLAB website, and there, if you have MATLAB installed in your laptop, then it is very easy. Right, you can have AutoSAR toolkit downloaded, and you can look into some examples in the AutoSAR toolkit and try to learn from that. Right. So career opportunities abroad also, a lot of career opportunities are there. Many companies in Europe, mostly Europe is actually a very big market for electric vehicle jobs. Okay, so if you plan for higher studies and if you want to work in this area, you can try applying for maybe some jobs, some universities there which are offering you some kind of electric vehicle specialization, and easily you can get jobs there. Okay, a lot of requirements are there. Germany is actually, as I told, Germany is actually a big market. A lot of electric vehicle companies are based in Germany, right? So a lot of applications can be obtained. Now, research opportunities, as I told you can look into MS courses, or you can go for PhD after that, right, in electric vehicle technology. Mobility technology is actually going to give you a good future. Okay, because now when we consider an electric vehicle, if there is some fault in the electric vehicle, a simple you cannot take it to a ordinary workshop, right? Because it is difficult. If you work on the battery pack, you will see that it's a 48 volt 200 ampere hour lithium ion battery pack. That is the level of energy which is there inside the battery pack. right? And if by mistake you have to, you happen to touch somewhere which is not, if you happen to touch the positive, or if you happen to touch somewhere where the power flow is happening, you will surely get burnt. Okay, so that level of safety has to be adopted, and it cannot be taken to a simple workshop. So there also a lot of scopes are there. If you want to have some careers in maintaining, or maybe a maintenance factory for electric vehicles, or if you want to start a workshop on electric vehicle systems, that can also be a good opportunity. So a lot of research is there in this, and it is very sad part that many people are not interested in coming into this area. It is actually a gold mine, if you can say. It is actually a gold mine. Lot of opportunities are there, but still many people are not interested because they're not able to understand the interdisciplinary nature of this. And if you all are interested, please try to start a career in this electric vehicle technology. Even in India, we have IITs. Lot of research laboratories are there in IIT Guwahati. They have a very good MS program in e-mobility. Then IIT Madras, we have the automotive controls laboratory. So this is under Dr. Shankar Ram. He is a very good professor, and he looks into this. And also there is another professor in IIT Madras who is also working into the other side of that. Shankar Ram sir is working on the drivetrain. Other professor, I forgot. He is actually very famous in Kerala also. He had come for e-mobility. He is actually a consultant for Kerala government. I'm sorry, I couldn't remember his name. So that professor is also very much working in this area. Okay. Then you have in IIT Kharagpur, we have Dr. Somnath Sen Gupta, who is working in the advanced technology development. So he has a big data project which is actually happening now. Right. So entrepreneurship in e-mobility, these are some of the areas which our students are also working on. Developing on charging infrastructure, where we are working on how to make smart grid-based charging stations for electric vehicles. Right. Then we have also on smart power regulations, where how to develop controllers, converters for the charging mechanism, or how to improve the efficiency of the system. Then self-driving system, BMS, battery packs. These are some of the key areas. Now, what are the key technology challenges that we can expect from these electric vehicles? So here you can see, this is a figure of Tesla Model S, which has caught fire because of thermal runaway, where the battery BMS failed. Okay, actually the battery management system failed, and because of that, what happened is the battery pack could not withstand the discharging, or the C rate at which it is discharging. So because of that, thermal runaway happens, and that will lead to complete damage and fire. Right. So this is one example of that. Similarly, Neo is another brand in China, which had a similar problem with the BMS, and because of that they had to recall around 4,800 units. Right. So that is a big loss to the company. So these are some key problems which we can identify when we talk about electric vehicle technology. Right. So battery management system, as I told you, I'll not get into much into this. Battery management system, there are a lot of precautions which we have to take in when we talk about lithium-ion battery pack, because lithium-ion battery pack is very volatile. So one area or one focus on charging is on CCCV, that is constant current, constant voltage charging, where we regulate the type of charging which is happening to the battery pack. And also we have something called as cell balancing. Okay, there are different types of cell balancing: active cell balancing, passive cell balancing, different mechanisms of cell balancing are there. So that is another key area which is focused upon. Right. Now, as an example, I just want to talk about this. This is a process which is called as platooning. Okay, and this is as part of the autonomous vehicle or vehicle-to-vehicle communication scenario. So, if you look at this figure, can someone tell me what is identified here, or what can you understand from this figure? If someone can tell me. This is actually two trucks which are moving on highways, right? And any information that you could understand, anyone? What might be happening here?
So is it air resistance?
Yes, sir. Correct, sir. So this is actually what we know as aerodynamic drag. Okay, so you can see there is a air resistance which is coming in front of this front vehicle, right? Second vehicle, third vehicle. You can see, the same vehicle in three different scenarios. So in front of the vehicle, you can see that there is a huge air resistance which is happening as the truck moves. Now, if you look at the following truck, you can see if we can optimally place the truck, what is happening? if the truck distance is more, in the third case you can see the truck distance is more, then more air resistance is coming on, or aerodynamic drag is coming onto the following truck. But as it becomes closer, or as it comes closer, you can see the aerodynamic drag is reducing. Now this aerodynamic drag is one crucial resistive force which is acting on the vehicle, and because of that what happens, the vehicle mileage can be reduced, right, or the vehicle performance is reduced, right. So now imagine if we can have a system where we have vehicle to vehicle communication happening between these two vehicles, and this vehicle gets to know that if I am maintaining say 5 meter distance from the front vehicle, right, I can avoid aerodynamic drag completely, and if I am able to avoid aerodynamic drag completely, then my mileage will increase, right. So this is what is platooning, or this is what is the scope of platooning, which is being utilized a lot. You can see this is a paper which is developed by Dr. Norby in 2014. They are doing study on the aerodynamic drag of platooning trucks. Okay, so, so this is just an example I am talking about. This is the scope into which we have, which we can think of, right? A lot of opportunities are there. So platooning is one area which is highly researched in UK and in Europe mostly. Right, and this is very interesting figure on anti-lock braking system. This image itself will tell us what is ABS. We might have heard about ABS in vehicles, right? We know Royal Enfield, right? Royal Enfield is very infamous because it doesn't have ABS until the recent launches, right? Before that, they didn't have ABS, right? Now government has made ABS strict. So can someone tell me what is actually ABS? Just looking at this picture, you can identify what is ABS.
The rear wheel won't lock.
Right, rear wheel
when you
lock.
brake, hard braking.
Right. So why doesn't it break, or why doesn't it get locked?
Sensors detect that the rear tire is sliding, not turning.
Correct. Yes. So the problem with the vehicles without ABS is the wheel gets locked, right? The moment we catch or hold on to the brake, what happens? The wheel the disc comes and it presses onto the wheel, and the wheel gets locked, right? So there are two types of braking. You have disc brake and drum brake. So based on the vehicle, if it is a two-wheeler or four-wheeler, the braking will vary. So if I'm holding the brake, immediately the wheel will get locked. Now that will cause a lot of chance. There is a lot of chance that we might fall. If I'm traveling at say very high speed, 100 km per hour, and we'll get if the wheel suddenly locks, we'll trip over and we'll fall. That is very dangerous. So ABS, what it does is it provides pulsated braking. That is what we can see here. We can see the moment I hold the brake, there is braking happening here. Then what is the ABS doing? It is releasing the brake. Right, here braking is not happening. Again, you can see again the ABS is implementing the brake, or it is implementing or catching or holding the brake. So again we are braking. Again it is releasing the brake. Again it's braking. Right. So this is a simple technology, right? A simple logic, not simple technology. It is a very simple logic. So ABS implementation helps us to actually reduce the stopping distance as well. Right. So this is the point I want to focus upon here is we can also come out with such interesting ideas which can easily be implemented. Okay, on some kind of projects, or even if you try out some small prototype also, that will actually add on to your resume, and you can be more employable in that scenario. Right. So this is what I was talking about: battery swapping policy to promote EVs. The Union Budget 2022-23. They have decided to promote battery swapping technology, but how effective is it? I don't know. But it is a good move actually. We can plan on having because a lot of companies are coming into this. There is one very famous company which is known as Sun Mobility. I hope you have heard about that. Sun Mobility was started by Chetan Maini, and Maini Group is the first founder of the Reva vehicles which we see. We cannot call them as the first electric vehicle developer, because I think in Kerala only we started with the electric vehicle. First electric vehicle was launched. But Maini Group launched the commercial Reva vehicle, which used the old box type vehicles. So they then sold it to Mahindra, and then they moved into the battery swapping area, where they are going into the microgrid based charging station, where they have a solar panel, and then they have this battery swapping stations which are available. Right. So this is actually a welcome move. And if you look at most of the budgets which are coming in, even if it's Kerala government or Karnataka government or Indian government, there is a huge thrust for electric vehicle and electric vehicle subsidies, as well as for startups. Right, all those things are being focused upon. Right. So that's all. I'll wind up with that. So this was our very good team. These were 5 students of that particular team who were part of KPIT Sparkle. We were in top 10 during that in March 2020. This was before the pandemic. So there they had worked on upon a hybrid electric vehicle prototype, and it was well appreciated. And these were the students who were working on that area. Now, one focus, one main thing that we do in our labs is we don't look much into the merits, that is how well is your academics or how good you are in your studies, because if you have a passion towards the technology or development of the technology in electric vehicle, you can come and join. Like that is the policy that we follow. I'm sure your research cell will also be following the same pattern, because research doesn't, you cannot equate it to academics. Even if you have very high marks, that doesn't mean that you are very good in research, right? So it is actually a passion. So even if in this students, there are some students, I will not show you or name them, but who are not that good in academics, but still they are excellent in their e-mobility related activities, and they have actually secured very good job. Right, so I'll stop with that, and I'm happy that some of my research team students have also joined in this talk, and they are also there. Okay, so they are very much that is the current second year students or third year students who are also working into development of various e-mobility technology. So that's it. Thank you. So if you have any questions, we can discuss.
Sir, I actually have one question. By the way, good evening.
Yes, yes.
The question is, what's the state of batteries in a vehicle when it's being charged? Is it in a series or a parallel?
No, I didn't get you. What is the?
In an electric vehicle, the batteries are arranged in series, right?
No, it's not like that. It is actually see, based on in one battery pack, we'll have some modules. Okay, so these modules will be connected together so that we obtain the voltage and current. Now, if we are taking a 18650 cell, 18650 cell is around 3.7 volt, 2.6 ampere lithium ion battery pack, lithium ion cell. So if I am taking a Mahindra E2O, right? Mahindra E2O will require 48 volt, right? So 48 volt is the terminal voltage. So 3.7 volt we have to connect it in series. 13 cells will be connected in series to obtain 48 volt. So there you have one string where there are 3.7 volt cells which are connected in series. So we obtain one string of 48 volt. Now I want 200 ampere hour. So one string will give me only 48 volt, 2.6 ampere hour, because that is the current will not add up, voltage gets added up. Right. Now if I want to have 200 ampere hour, then I have parallel strings connected. So these parallel strings, maybe 2.6, maybe I'll have around 80 strings which will be connected. So 80 into 13, that many cells will be required. Okay. Now if I'm connecting, now I cannot create it as a single battery pack. So what I do is I'll divide the strings into modules. Okay. So modules will be say 5 strings together will be one module. Another 5 strings together will be another module. And now these modules will be then connected together to form the battery pack. So that is how usually the battery packs are made.
Okay, so my question is, what if we can charge these multiple batteries parallelly? Each battery gets equal amount of power that way, so we can reduce the charging time. That's the
multiple batteries in parallel, in the sense in one battery in one car.
Yes, we are using multiple batteries instead of multiple packs. Okay. Now my idea is we will using a relays and a microcontroller. We will adjust the circuit in such a way that when we plug in the charging port, the net circuit will be made in such a way that it's parallel. Using some part of the switches, that means electron switches will be closed and some will be open, and in such a way that the net circuit will be parallel. So equal amount of power will be given to those batteries. So if there are 10 batteries, we can multiply the power 10 times. So equal power into 10 batteries. So charging time can be reduced to 1 by 10. Logically, that's my idea.
No. If you see like that, see, one thing is, say we have 15 ampere lithium, 15 ampere charging point. Okay, so 15 ampere charging point means our source is providing 15 amps. Okay, so now this 15 amps, if we try to divide it into different battery packs, then how do we transfer the energy to all the battery packs? This is coming as a single, 15 amps is drawn by the load. right?
Sir, actually we have to develop a proprietary charger for this also that can deliver that much power.
No, no, but the
Yeah.
current drawn will be more, right? See, if 15 amps, if I'm saying, I think you are saying I have one battery pack which is going to take 15 amps, right? Another battery pack which is taking 15 amps. But then from the source, I have to give 30 amps.
Yes, sir.
No, that how feasible is that? Because yeah, conventionally, if we go for our home charging, I'm not discouraging you. I'm just telling. In our home charging, this 230 volt 15 amperes is our home charging system. Okay, so
Yes,
in our
yes,
home charging, we have a 15 ampere port which is available, which the
yes,
KCB will be providing, right? So
yes, yes,
now, if we have one more port, then actually our load is increasing,
yes,
right? So our home is asking actually 30 amps current.
yes.
So
Okay, I
that
understand.
slab everything will change.
Yeah, so can we do this like a charging station like that?
No, charging station also, there also you will be drawing current from KSEB, right? Or if you
Yes,
want a
okay.
microgrid renewable based charging station, then you will have to have a lot big solar system or solar panel network so that you can deliver the power. So,
Okay.
yes, yes. So, it's a good idea that you are working on this. Try working on the battery management side. That would be very good, I think. What you told is
Okay.
something called as self balancing. Okay.
Okay.
So, look into that. That is very interesting.
Uh, okay. And now one more thing is, when we are riding a motorcycle,
Yes, sir.
when we enter into a corner, we dip the motorcycle into an lean. Okay, so if the lean angle go past a particular point, there's a chance that we might lose the balance and.
Correct.
So using a small gyroscope or small sensor like that,
Yes, yes.
we actually measure the lean angle, and in such a way that in aircraft there is a mechanism called a stick shake. That means if a particular point, if the aircraft loses lift and the aircraft begins to stall, the sticks that are used to control the airplane by the pilots or the joystick will start to vibrate, indicating that there is a loss of lift. So that's the mechanism. Like that, we will vibrate the handle to make the rider know that okay, you are about to reach the maximum point. Beyond which you will lose control. That also a system I'm working on. Is it
Yes, yes,
feasible?
yes, yes. That is very good idea actually. And also, maybe you can take it a step forward where you can actually have. You might have heard about this. What is it? Inverted pendulum. You can just search inverted pendulum technology. They're very simple PI controller based technologies they are using. So what happens is you have a pendulum which will be like this, right? So we'll be keeping it like this. So when we move it, what happens is there are chances that it will fall. So there will be a small motor at the bottom which will be regulating the fall, and so that it always remains steady, right? So what you told is a very good idea. Along with that, if you can have this PID controller based system also, which controls a motor, right, to regulate or to protect from falling down, right? That also you can maybe take up as a future scope.
Yeah, now other thing is using LiDAR or sensors, we will actively monitor the blind spot of the car or vehicle, anything such that. So if a driver is trying to execute a turn, and if the sensors detect there is an vehicle or a person in that particular area, the system will prevent the wheel from turning. Okay, so that an accident can be avoided.
Okay, wheel from turning is not good actually because driver should have the entire control. Maybe you can have an alarm provided, right? Blind
Yes,
spot alarm
okay.
you can have. That is good. And LiDAR might not be possible. It is very costly. The camera will be very good, easy.
Okay.
Yes, yes.
Thank you, sir. That's all.
Yeah, thank you.
Hello, good evening, sir.
Yes, yes, sir.
I have a doubt, like how we communicate with the vehicle-to-vehicle communication. That's a kind of communication. What are the protocols are using in vehicle-to-vehicle communication? Like,
Okay, vehicle to vehicle communication, we have something which is known as VANET, which is very famous now, Vehicular Ad Hoc Network. Okay, so it has a range of around 1 kilometer, I guess, right? And so what happens is they are using a heterogeneous based communication where we have an antenna, right? From antenna we'll be sending out the information, right? And that information will be captured by the other vehicle. And when we are sending the data, we have to encrypt the data so that it doesn't get interfered by others, so that cybersecurity issues can be avoided, and then it will reach the other vehicle and you capture it. Now, as of now, I have not worked on the VANET side, so I'm not much sure about how it's working. We are usually we are working on the Wi-Fi based module, uploading the information to the cloud and working, or maybe IFTTT based like that. But VANET as such, I have not worked that. So that is the logic behind that. They will be using VANET, or there is another method which is called a heterogeneous communication, where they use something which is known as ad hoc on-demand distance vector approach, where they have this GSM, our mobile cellular SIM, right? SIM-based message can be transferred from one vehicle to another, and that information will be captured and processed. But the problem is, there we should have a service provider, maybe something like an Airtel or an aggregator, which will receive this information from one vehicle, and then it will act as a mediator. It will send that information to the other vehicle. So only the service provider will get to know from which number to which number the information has to be sent, because we don't know what is the number of the vehicle in front of us, right? So that is the model that I have come across.
Okay,
So
sir. Thank you.
can we use radio waves, short distance radio waves? So it's like a circle of, a small circle, and that vehicle can communicate with nearby vehicles, so that we can avoid that intermediate. We can directly communicate from one vehicle to another vehicle.
So the problem is radio waves. I guess it is FM radios, FM waves, right?
Yes.
Yes. The problem there might be security is an issue, right? Because we are sending our vehicles information out, so anyone can tune into that.
Yes, but certain bandwidth are restricted. We can't buy a radio, the receivers with that wavelength. So commercially, it is not available.
But still, I guess if you see, if my frequency is 93.5, we have FM, right? So other guy is also 93.5, then communication can be said. But anyone who tunes into 93.5 can get into that information, right? So if I'm sending some information, that can also be captured. So
Yes,
I think that is why, radio waves, they are not much promoting, even because mostly companies will not do that, because they want full security. That is what cyber security, lot of scope is there. How to work on cyber security, big data for computer science students. These are some areas. Yeah, so that is my understanding on that.
Hello, dear participants, do you have any further doubts?
You can ask. I think now our time is coming to an end. You can ask at least one question from any of the participants.
So one more thing.
Yes, please.
In an electric vehicle, usually we use batteries to power the motors. Okay, so when a vehicle is accelerating very hard, the battery will drain very quickly. It will lead to overheating and all. So can't we use capacitors, ultra capacitors for that? That can store a higher amount of energy, and that won't have much issues while discharging at a higher rate.
Yeah, capacitors actually a lot of people are working on capacitors. So supercapacitors, what they are doing is, supercapacitors is used as a storage for regenerative braking. Right, when we are having electric vehicle, now most of the vehicles are coming with regenerative braking. So when you are implementing regenerative braking, there is a spike in energy which is coming, and which will be captured back onto a supercapacitor. So that technology is there, but problem with capacitor is its capacity is very less. Okay, when we talk about an electric vehicle, we want to have a assurance of this much range, right? And we also want a continuous power which has to be delivered. Okay, but capacitor cannot, or a supercapacitor cannot assure that. So because of that, because we will not be able to control the discharging which is happening from each capacitor. If I am making a pack with capacitors, it is very difficult to actually regulate which capacitor goes discharges more or less, right? So in that scenario, it will be difficult, but it is much easy to do that in a lithium-ion battery. So that is why mostly we go for lithium-ion battery pack. And lithium-ion battery pack now, another important area is thermal management system of battery lithium-ion battery pack, where the heat produced, as you told. There's something called a C rate. C rate. I think you might have heard about that C rate. Okay, so that is the rate at which the discharging is happening. If I have a 200 ampere lithium-ion battery pack, okay, and I'm accelerating full, and assume it is drawing 300 amps from the battery pack. Okay, my battery pack is rated at 200 ampere, but it is drawing 300 amps. So that means it is 1.5 times the rated capacity which can go. Right. So that is known as 1.5 C. Now, when I'm designing my battery pack, I have to ensure that my cell that I'm taking, that the 18650 lithium-ion cell which I'm taking, should be able to do that. Right. Because commercially available cells, if you look online, you can see there are cells which are ranging from 48 rupees to 300 rupees. Okay, these 48 rupees cells will not be able to do 1C charging or 0.7 C charging. So that means you cannot discharge even 100 amps from a battery pack. Okay, but if you're going for a better quality cells like Samsung cells or Panasonic cells, some of them can go up to 1.5, right? And if you go for very good quality cells, then Tesla is manufacturing their own cells. Okay, some are taken from Panasonic, I think. So they can go up to maybe 3C or 4C. That is 3 times the rated current. So 600 amps also you can give, right? So these are so when we talk about that area also, thermal management system is very important. Heating up of the battery pack will reduce the life. Right. A typical Mahindra E2O which we have, it is going to cost you around rupees 7.5 lakhs. Okay. Now that 7.5 lakhs, out of that, around 3 lakhs is for battery pack alone. Okay. Now, assuming we want to use that vehicle for say some years. Okay. Now they are expecting a range, a lifespan of sort of 5 to 7 years. Okay. Now imagine every 5 years, if you are going to buy a new battery pack, again you are spending 3 lakhs. Okay, so the good things that the electric vehicle is providing by maybe reduced emissions, reduced charging price, low running cost, right? All that is overtaken by this battery pack cost, right? So the battery thermal management system should be very strong so that we can try to extend this 5 years to at least 10 years or above. So then, if after 10 years, if I'm investing in a battery pack, then it is logical. But if I'm investing every 5 years, if I'm investing 3 lakh in battery pack, that is no one will buy an electric vehicle, right? So that is one area you can also work on. Yes.
Sir, what I'm actually suggesting is a hybrid system, okay? A hybrid system where the batteries will be constantly supplying the energy, but when needed, this capacitors can
Yes.
discharge.
Yes. That can be
Hybrid
done.
system.
Yes, that can be done. That is what regenerative braking. You can charge the capacitor, and when you want that boost in power, you can make that capacitor discharge. That can be done. Yes.
Okay, I think that if there are further no other questions, we can wind up this program.
Hello, good evening.
Yeah, please, you can ask.
Yes, sir.
Actually, I am still a student of electrical engineering, but in a formal way. I have few doubts. One is actually you are talking about so many research areas at here at DC Bangalore.
Yes,
So
yes.
what is how do you prioritize your areas for research?
Sir, actually, we have a lot of other faculties also who are working in. So it's like we have different teams. So electrical engineering will have some 10, 15 students who are working. Okay, then computer science will have, electronics will have. So finally, at the beginning of the year, we'll have the discussion with the students and we'll try to formalize some projects which is interdisciplinary and which is relevant to electric mobility. So we'll have one project with a lot of students from different teams. So similarly, we'll have some 4 or 5 projects which we'll be running parallelly. Sir.
My doubt is whether you are identifying the research areas internally, or are you taking any kind of sponsored or requested research based on the industry inputs?
We have, sir. Actually, we had. I mean, some industry requirements will come in, but it's not like because we are. I cannot say that we are into the full-fledged product development, right? These are all student-based projects, right? So it is not industry-ready projects, but we get inputs from industries. They say that, for example, one company was there which was working for Ola. They wanted to develop one range estimation module. Okay, so that is one input which they had given. So I mean, it's not like they are investing into this, okay, but raise the requirement and we try to develop that technology for them. So it will be a prototype model, which if they like it, then they will scale it up to their industry levels.
Then regarding the battery chargers, initially I found we were specifying based on AC input. The chargers were classified
Yes, yes,
based power rating and the nature AC DC like that 3.3, 15 kilowatt like that, 22
yes, sir.
kilowatt.
Yes, yes, sir.
But this is based on the source, right? Actually, is there a classification at the load side, because charging finally happens at the DC side only?
So this is actually the standards that we follow. This is charging standards which are rolled out in India. So
Okay.
yes, sir. So this is like government approved standards of charging, which is practiced in India.
Okay, okay. So
Yes,
basically for use with our grid,
yes,
as
yes,
a of the grid, these are the ways to connect to the grid like
yes,
this.
yes, sir. Yes, sir. Correct.
Excuse me, sir. This is Amit from Christ University.
Yes, Amit.
Sir,
We
Parag,
have
sir, can
three.
I add on to that?
Yeah, sure,
Add
sure,
on to
sure.
that.
Yes, Amit. Yes, sure, sure.
Sir, there will be different ratings for each that charging port, sir. We are at the load, sir. There will be some certain logics which we use. So, like in computers, when you like example, if in computers when you plug in USB, you can transfer all the files, and there will be logic to identify the USB as one sort of communication between the PC and the cable which we are giving. It can be anything. Instead of HDMI, we are using USB like that. We can use. Likewise, we can use this type of connectors to the load also. Like we have to do some programming or use some devices to get that logic to charge to charge the battery or some loads, etc. That's it.
Yes, we have
That's it.
CAN bus communication, which will be happening between the charging station and the vehicle through CAN bus interaction.
Okay, okay.
Yes, sir.
One actually, I also heard the battery management system based on prediction, based on kind of usage of power.
Correct.
Is there any technology where we can simply sense what remains in the battery? If I think measuring voltage alone does not tell you anything,
No, sir.
but voltage and some other parameter, is there any technology where somebody which is employed somewhere?
Yes, yes. Actually, yes, Amit. We want to add?
Yes, sir, you tell, sir, afterwards.
Yeah, yeah, okay. Actually, we have terminal voltage method, which, sir, as you told correctly, it is not accurate. We follow that the data sheet of 18650 cell, and we check map the voltage to SOC, and that is actually a good method. So, other alternative is we have coulomb counting method, where we have somehow count the coulombs, that is the current flow. Based on we have a current sensor, right? And based on the current flow, we will have a database, and from that we can actually predict based on the current flow what is the amount of charge which has been discharged. For example, if I have a battery pack 100% 100 coulombs, okay, I have created a database which has 100 coulombs, which indicates 100%. So that means if I'm counting the coulombs, I can say that at 50, if the current is flowing like that, then around, if it reaches around 50 amps, that shows that my 50 coulombs have been counted. That means SOC is around 50%. So we can map it like that. So that approach is called as coulomb counting. Then there is another method which is called as a joule counting method, where we have energy evaluation is done. So that is also another method which is used.
So actually, these also should take in places where we are using kind of some regeneration. This also should take into account what comes back, right?
Right. Yes, yes, yes. We have to monitor that also. What is the coming back? That is why usually if we want to make regeneration, we maybe do it into the battery pack, or we can have a separate super capacitor or something where we can store the energy, so that trouble can be avoided.
But super capacitor, we have a limit to the storage,
Correct,
right?
correct, sir, correct. we cannot charge it to any extent. There is a limit. Saturation will happen. So if you want to bring it back to the battery pack itself, then we have to monitor the incoming users. Yes.
Thank you. So you have given a very broad spectrum of this EV from starting with the basics, and actually that was a very informative thing you presented. Tesla is ahead of Toyota in case of
Nice.
EV.
So that is not
Yeah.
it is market capitalization. Their market net worth is that much now. Very high, very high actually. With they have this other SpaceX programs also coming in. So that is also a subsidiary of Tesla. So, but Tesla as such has picked up a lot. This three times time out.
Okay. Okay.
Yes, yes.
Okay. Thank you.
Thank you, sir.
So I think that with this question we can wind up the program.
Okay, sir.
So I am coming to a formal conclusion or a vote of thanks. Uh, Actually, the program today we conducted is a very informative and enthusiastic. So many participants, mostly from students, faculties, and other industrialists, who participated well, and they have encountered a lot of questions. And our guest, Dr. Parag Jose sir, had answered it very well. So for us, for Lord College of Engineering and Science and Technology also, it's a good opportunity to know more about the trends and the career opportunities in the electric vehicles, and what is the research status here, and what is happening in various areas or various institutes in and out of our country. So we get a lot of information on that, and many students actually they get an enthusiasm to pursue more about these things. And I think, sir, so many students will contact you, sir, after this
Sure, sir. Sure.
webinar. Yeah, yeah. So
Whatever is
many,
possible, we can.
yeah. So many messages like will come to my mobile also. So at this occasion, I give my wholehearted out of thanks to Dr. Parag Jose, the researcher and the assistant professor in the Christ University, Bangalore, for giving a valuable and wonderful speech. Thank you, sir.
Thank you, sir. Thank you. Thank you to the research team as well as to Mother Engineering College, and again thanks to Johnson sir, Sarin sir, as well as Dion for the arrangement. Thank you, sir. Thank you very much.
Yeah, and Dr. Sajin sir also, he is the person who introduced Dr. Parag Jose sir, and our lot of thanks to him too, and the research team behind you, and every person we are very much grateful. And apart from this, all the participants, various faculties, students, etc., we are giving a wholehearted out of thanks to all. So we will come with another program on the next month. This research webinar series 7th edition with a new topic, and we will inform you all these details, and the students, the people who attended this program will get you should give your feedback in the group. After that you will get the certificates, the e-certificates to your mail. Thank you all.
Thank you, sir. Thank you very much.
Yeah,
Thank you.
formally our program is coming to an end. Thank you.
Thank you, sir.
Yes.
Thank you. Yes.